So good evening. We are going to finish out section 2.2 tonight by talking about the difference quotient. And like you might think, because of its name, the difference quotient is a little bit different than anything else that we've done, okay? It's different than anything else that we will do in this course. But it's very important because it's very foundational to some of the things that you will do if you ever think that you might take calculus, okay? And here's what the difference quotient is. Imagine that you took the slope formula, but you wrote it in function notation. And here's what I mean by that. Let's say you took this graph over to the left. First thing I want you to notice is this is not a straight line, this is a curve. Normally when we talk about slope, we're talking about a straight line. With the difference quotient, that won't always be the case. The other thing that I want you to notice is that there's no numbers on this graph, and that's intentional. So let's say that I pick a random point. Let's say this is the point that I pick right here, and I want to label it. Well, how do I do that with no numbers? Well, I just say this point has coordinates x comma y, or in function notation, that's x comma f of x. Then I pick another point, okay? Let's say I pick a point right up here. And I say, well, what are the coordinates of that point? Because I still don't have any numbers. Well, what I do know is since this point is to the right of the first one, that purple one there, what I can say is the x-coordinate of that point is x plus something because it's farther to the right than the first one. And we'll call that something h. So the x-coordinate of this second point we're going to say is x plus h. X could be 2, x could be 3. We're not sure exactly how much farther to the right it is than the first point. And then that would make our y value f of x plus h, meaning that y depends on whatever x plus h is. So how then do I write the difference quotient? Well, start with your slope formula. y2 minus y1 over x2 minus x1. Well, look at the 2 points that we chose. If we plug in the coordinates of those points, what would that look like? Well, y2 is f of x plus h, okay, minus y1, which is f of x. What are my two x values? Well, x2 is x plus h, and x1 is just x. And look what happens on the bottom. Those x's cancel each other out, and all I'm left with is f of x plus h minus f of x over h. That's it. That right there is what is called your difference quotient. So it comes directly from the slope formula. It's just written in a completely different way than you've ever seen it before. So let me give you an example of how to go about using the difference quotient. It says for the function f of x equals 2x minus 3, find and simplify the difference quotient. And just a reminder here, this is a line, right? So if the difference quotient is basically the same thing as slope, then when I find my difference quotient, I should get 2. So that'll be a way of us checking ourselves. So here's how I start off with the difference quotient. It says, first of all, find f of x plus h. So that means go to that function there, 2x minus 3, and plug in x plus h. So wherever I see an x, I'm replacing it with x plus h. Okay? So there's f of x plus h. Well, what's the next part? The next part says minus f of x. Okay? So I put my little minus sign. What's f of x? Well, f of x is just 2x minus 3. That's what they tell me in the problem. So there's the second part. And then you have a third part here. And that third part is just always part of the difference quotient. It's just h. So I just write it down there. And that's it. So at this point, all that I have to do is simplify some things. Okay? Well, the biggest thing I've got to do here is to distribute first. So I take the 2 and distribute it to the x plus h. Bring down my minus 3. And then I distribute the negative. So negative 2x plus 3. And the h is just kind of there. We don't do a whole lot with it at the very beginning. Well, now look what happens. The 2x and the negative 2x cancel each other out. The negative 3 and the positive 3 cancel each other out. And so all that you're left with is 2h over h. What happens to those h's? They also cancel each other out. form than you've ever seen it. Okay? So let's look at a different example. Example 5 says for the function g of x equals, and then they give us a quadratic function. So let's think about what that means for a second. Number 1, if I have a quadratic, it's not a straight line, which means my slope changes depending on which 2 points I pick. So this time when I do the difference quotient, I'm not going to just get a number. There are going to be some letters mixed in with that. Okay? So let's start with f of x plus h. Okay? So what would that be? Well, that means go to the function that they gave me, and my input value is now going to be x plus h. So anywhere that I see an x, I replace it with x plus h. Okay? So there is f of x plus h. What's the second part? Well, the second part is minus f of x. So I put my minus sign down, and I write out in parentheses f of x. And just a heads up there, the reason I'm using parentheses is because I'm subtracting multiple things. So in just a minute here, I'm going to end up distributing a negative. If you don't have parentheses there, you will get some of the signs wrong. Okay? Then my last part is h always just sits there for the time being. Okay? Well, what do I do first now that I've got to simplify some things? Well, the first thing I've got to take care of is this right here. I have an x plus h squared. So I'm kind of going to come over to the side here and take care of x plus h squared. So that's x plus h times x plus h. Well, I'm going to have to FOIL that or distribute. So x times x is x squared. X times h is xh. H times x again is xh. And then you have plus h squared. So what does that become ultimately? That becomes x squared plus 2xh plus h squared. So all I did there was I simplified the x plus h squared. So now I'm going to rewrite everything based on what I now have. Okay? So nothing has changed except I figured out what x plus h squared is. Parentheses. Okay? Well, what's my next step? Well, I've got a ton of distributing to do. So my step 2 is to get rid of all those parentheses. Go through and distribute everything that I can. So the 2 will get distributed to the first parentheses. Okay. The negative will get distributed to the second parentheses. And another negative will get distributed to the last set of parentheses. And again, h is just there. It's kind of lonely sitting there by itself. Okay, now that we've taken care of all of our distributing, what can I cancel out? Well, the 2x squareds are gone. The negative 3 and the plus 3, those are gone. Minus x and plus x, those are gone. So what do I have left? Well, let's see here. I have a 4xh. And I have a 2h squared. And a minus h on top. And then I have an h on the bottom. Well, what's happening here? Look at what all 4 of these terms have in common. Every single part of this fraction has an h. That means I can cancel out an h in each one. So this h is gone. This h is gone. There's 2 h's here, so one of them disappears. And this h is gone. Well, we got to leave a 1 as a placeholder here. Okay? So now what do I have left? All I have is 4x plus 2h minus 1. That right there is my difference quotient. What does that mean? That means if I knew what x was, and think back to the picture, x was that x coordinate in my first point, and I know what h is. H is the distance between the two x coordinates of your points. I could plug those in and get the slope between any 2 points on that graph. That's what that is telling me. Okay? And so right there, that is the end of our discussion of the difference quotient. I know this is a little tricky. So if you have questions, please, please, please ask.